We had the idea to show the new UI that comes with YugabyteDB. And first, I will share my screen and show what we had before. Before this new UI, when you start a YugabyteDB cluster, you have a web console exposed by the master, because the master knows all other nodes of the cluster, and exposed on port 7000. And basically, so this web console was really to see the minimal things, how things are working, and some statistics also about what is running. Basically, information about the cluster, replication factor 3 to be resilient, the number of nodes, I have only 3 there. And we had also information about the tables there. Namespaces are basically the Postgres databases or the Cassandra namespaces. The tables, I still use this console when I want to see more information about a specific table. Where are the tablets, for example, where are the leaders? But for example, on performance, there is not a lot there. We can see the tablet servers, if they're up or not, and the basic statistics. And then the new one, let me just go to the port where it is exposed, 15433. And that's the new one. So much nicer, of course, and more user-friendly. First, the overview of the cluster. I have the same information, but meaningful, the replication factor, fault tolerance, also something that we didn't have. You just want to know that you have a fault tolerance at region level. Because basically, this is a cluster deployed on 3 regions.
Show the regions. You have 3 nodes in total, and it means that every node is located in a different cloud region.
Yeah,
Correct?
if I look at the list of nodes, this is where I will see them with their region. And also the read-write operation, the same statistics, but only what is interesting that fits in the screen. You can see per zone, region, or server, the basic performance statistics and the number of tablets also that are useful to see if everything is balanced. But you can have a lot more information if you want the memory used and provisioned, for example, for each server.
Right now, let me show you how to use this performance dashboard if you want to detect and take a look at live queries or slow queries. So my use case would be I want to find queries that have a suspiciously high latency, and then what would be my optimization flow. So let me start this application in Docker. This command will start this market orders application. This exception is harmless. It basically says that the schema already exists, and you can see that right now the application keeps inserting traits into the database cluster. So now let's jump back to the cluster, to the performance. Yeah, you can see that this chart goes up. We have reads, we have writes. This is what I wanted to see. Also, if I go to the cluster, so here is I want to see some numbers. Yeah, you can see I keep refreshing, and their cluster is load balanced. And now let's go back to their live queries. I'm not sure that those queries are live.
Actually, live queries shows what is in pgstat activity. So the queries are live in the sense that it's either a query that is currently executing or the last query executed by an idle session. So it's live in the sense where the response has been sent to the client, the application, and the application didn't run anything else.
Actually, that's a good point, because that's not the behavior I see in the YugabyteDB Managed. In the YugabyteDB Managed, probably we had some extra logic that will not show those queries that are already completed.
Okay. If you click on one of them, you will have more detail, and I think we will see the status. Yeah, status idle means that this one is not currently running. The session is connected, has run this statement, commit, and now is idle with nothing to do.
Let's go to the slow queries. So here is under the slow queries, This is one of my group buys. Their average latency is 40 milliseconds. Probably I don't want to optimize it, but let's take a look at this query. This query basically calculates the total number of trades. These fill or kill trades, you see this? It's a special type of trade. And I would say that the latency can be definitely improved. So imagine that this latency looks really high. How can we improve it? Let me connect to this cluster instance using PSQL. My host is local. Port
Well,
number.
connect. I will mention that usually I compare the latency with the number of rows. And in your case, you had a high latency for a small number of rows. So there is probably something to optimize. Probably it reads a lot to return
Yeah,
not
actually, let's
everything.
copy this statement, right? I want to copy it. And let's check the execution plan. So actually what the application logic checks, it checks this, fill or kill. Yeah, we have that the number keeps changing. We keep inserting and explain analyze. We'll show you that we are doing the full scan. That's probably the worst scenario you want to have. You don't want to have a full scan because generally speaking, count is not the best operation in distributed system. But let's say if you want to do the count of a data subset like here, then it's pretty reasonable. But
it could be worse because here your count, I see partial aggregate. At least it is counted on each tablet.
Yeah, at least, yeah.
That's an optimization we have.
Actually, good point. What Frank is saying that at least the node, the coordinator for this request doesn't need to pull the data from their storage and then do this aggregation. At least on the storage side in our DuckDB storage, we can execute the count of the subset of the data on that node, and then the final numbers are delivered to their coordinator.
And the filter also, I see remote filters. Those were scanned, but at least not move through the network.
Excellent. But nevertheless, we have this full scan. It means that this operation is, I have 3 nodes cluster and this operation executed on those 3 nodes. At least, yeah, we have this optimization with the push downs. But the more data I have, the more time it will take to execute this request. What we can do, at least the more straightforward approach, let's create a secondary index. So right now I don't have any secondary indexes for this table. Yeah, I have only the primary one. And we can create that index for this trade type column. Okay, so create index, let's give it a name, trade type index. And on trade type. Waiting. So, and let's remind ourselves, yeah, the latency was around 23 milliseconds without the index. Yeah, it takes, when you execute DDL on a distributed transactional database, it will take more time, but at least you will be consistent. That's the price you pay for the consistency.
The fact is, when you create the index, we do not lock anything. That's the difference with Postgres. Postgres needs an exclusive lock on the catalog, very short, but needs it. And to be scalable, we don't have it. And then by default, the create index just waits 1 second to be sure to get all the heartbeats about the new version of the catalog. So basically, creating an index on a small table will still take 1 second just because it waits to be sure that the catalog is synchronized.
Excellent point.
But it's created online, and usually it's not a problem. On a big table, that's 1 additional second is nothing.
Okay, so folks, here is the index it's created. So right now, if we run the same request, explain analyze, it takes 15 milliseconds, 12 milliseconds, and before it was 28 milliseconds. So 2 times better.
And now you are scalable because before the time was proportional to the size of the table. Now the time is only proportional to the number of rows that you read.
And also what's excellent is, see this, that's index only scan. We just We don't need to retrieve an entire row. We just go through that index, and as long as we are calculating the count, have everything needed, we just need to calculate the number of rows that satisfies the search condition.